systems.
It's strange. I was expecting this weird silence after this, like intro, and there was no silence. You folks were still chatting, which is perfect because this is exactly what conferences are for, right? For networking, meeting friends, again, making new friends, exchanging experiences and whatnot. This is exactly what you should be doing at the conferences. This is the primary reason to go to conferences. This is just an excuse, right, to visit like a few lectures. Yes, thank you for coming for this one. It's called Java 19 and 20, what's new and noteworthy. And in case you have missed that, it's one of these deep dives. Therefore, we have this lovely diver in the background, right? And it basically means that we are going to stay here for how long? Like 2 hours, right? 2 hours. Yeah, we'll be doing a new Java for 2 hours here. Right, so the plan for today's presentation is to go for slides, some kind of like intros or key points, or just to navigate us where we are, right? But also, or predominantly, I would say, it's about the demos, right? Because in the code we trust, right? There might be like specifications, they might be various wikis, ADRs, whatnot, but code actually tells us how the system behaves. Yes, very nice. I'm glad to see so many of you here. All right, briefly about myself. My name is Piotr Przybył. You can follow me if you wish, like Twitter, Telegram, or Mastodon. I'm software gardener. I also train people from time to time. My personal blog page is softwaregarden.dev. Should you be interested in some Java quirks, I don't know, IT Insight, pool life advices and whatnot. The slides are online, the code's online. So of course you're welcome to take pictures, right, as memos or whatnot. But you'll be able to like clone the repo and play whatever you wish, right, at home or with your friends at your workplace and whatnot. Yes, just to finish talking about myself, I've been doing Java since Java 1.3. I even backported some code to 1.2. So I'd say I saw quite a few migrations. Some of them were painful, some of them not. The question is, who are you? Lovely people. Who's doing Java? Okay, almost everyone. Who's not doing Java as a daily job? Okay, no Rust funds. I see. Yeah, they're busy doing other things. Okay, who's using Java 20 in production? Come on. Not a single person. Great, which means you're in the right room. Okay, Java 17. Oh, like 1/3, very nice. Java 11. Okay, Java 8. Still a few folks who would love to, but I can't. Okay, below Java 8, anyone? Don't be shy. We are all friends here. Okay, nobody. Okay, yeah. So I would say between Java 8, right, and Java 9 or 11, shall I say, because Java 9 is no longer supported by anyone as far as I can tell. Yeah, this is this sharp step or cliff, shall I say. But once you hit Java 11, I see really no reason why I shouldn't be using Java 20. But we'll get to that. Little warning, every person is a human being. Everyone can make mistakes or say stupid things, right? Myself included. Yes, so Java 19, right? Java 19 was released almost a year ago. It had 7 Java enhancement processes implemented, right? And here are the release notes. Should you be curious, just click and follow the link, right? Java 20, it was released, right, half a year later. And it has also 7 JEPs in total and also release notes for you, right? So these are the JEPs of Java 19. And as you can see, apart from this new port, everything else is a preview or incubator, right? Every JEP. As for Java 20, it's even better. Everything is incubator or preview. I mean, apart from the changes that are small changes like tickets or whatnot that weren't part of these big JEPs, right? So with scope values, record patterns, pattern matching, foreign functions, and memory API, virtual threads, concurrency, and vector API, we're going to cover almost all of them today. That would be all. Thank you. You have release notes. Enjoy the conference. Of course, I'm trolling. Yes. So the question is, shall I abandon the latest LTS and migrate to Java 20? And the answer is yes, of course. That's why I was surprised nobody raised their hands. This is the default mindset. You should be running the latest Java. Really. The whole deal with new Java releases is like this. Instead of keep us waiting for years, right? And postponing this by months and months and months and quarters maybe, or maybe even years, right? Now the release schema or schedule is different. The train leaves the station every half a year. And if a feature or a JEP makes it to that train, very nice, takes its place, and the train goes, right? With the feature or JEP. However, if the feature didn't make it, it doesn't board this train, it has to wait for the next one, so the train is not postponed. Right? And this is it. And yeah, of course, you're relieved from this unless you have like really good excuse not to do this, not to go for the latest version, right? And it has to be really good excuse, I mind you, right? So it's like really, we'd love to, but the key component of our business ecosystem doesn't work with newest Java, right? And we didn't manage to like replace it with something else, right? Because non-LTS versions are not banana soft or monkey soft or inferior versions or untested versions or whatever. LTS, I'm not sure if you should be quoting me on this, LTS is not a technical term, right? It's a business term. It means if you have an issue, right, and you're paying someone to pick up the phone when you call them and say, hey, we have a problem with Java, they will be doing this not for 6 months, but for however long they please, right? This is it. It comes to support, not like being like, I don't know, less secure, more buggy or anything like this. That's why you should be running the latest Java version, really. And there's been a change in the cadence, means the LTS will not be like, for example, that 11 and 17, it was 6 releases. Now we're going to have 4 releases, meaning Java 21 is going to be an LTS this autumn, right, this September, and I hope this really convinces you and the gold dragons of yours to upgrade to the latest version. And it's going to be awesome, as Americans say. Right, so in short, can you hear me? Okay, I thought for a second there was like a glitch with microphone. Okay, in short, there are no new language syntax changes like as a standard feature in Java 19 or 20, and because I'm covering the last year, like basically what happened since the last Devoxx. If you're looking for something like what happened to Java 17, 18, and the previous versions, you have to go for Devoxx channel and search for one of my previous talks, right? So I do it like a year, every year, I cover like latest 2 versions, hence 19 and 20 today. So there's been no language syntax changes as a standard feature, but we have changes in a preview, right? And there are changes to concurrency. There are changes to how we should process data, especially records, right? And still the native stuff is ongoing for like how to interoperate with memory, like native memory and calls to native stuff. And yeah. Because there, as you've seen, there are like preview features and incubator modules. You have to opt in to use them, right? They don't work by default. And this is implementation of JAP 12. And basically it boils down to using this -- enable preview switch for pretty much everything, like Java C, like the compiler, runtime, JShell, whatnot. So how do you set that in Gradle? It's more or less like this. If you want to play with the new, cool, exciting stuff and make sure that your software will be running or is capable of running with these preview features, because you'd like to choose to like check something, right? This is how we do that in Maven, more or less. C enable preview. In IntelliJ IDE, I didn't update to 20. Sorry. You also have to sometimes I mean, when you don't use like a build tool, or when sometimes there are glitches like with importing, then make sure, please, that you have selected this language level as latest preview, right? And you need to have like a modern version of your IDE to support that. Sorry, they're taking pictures again. Nice, very good. Sorry, yeah. They go to then Stefan will analyze this analyze it with his cool AI stuff, and I really have to look decent at least one picture, mind you. Yes, if you really need to understand how it works with class files and whatnot, please visit this video. Yeah, so concurrency. Concurrency, as we may know, platform or operating system threads might be too slow to create or too costly to create as well, right? So long time ago, when we needed to do something like we wanted our system to do like two things at the same time, we were forking the processes, right? And then we discovered processes are too heavy. So we have to have something cheaper and faster to start. So then we went to threads. And then turned out that threads can also be costly. So we have coroutines or Go routines, or we have like reactive approach, which is not only addressing this issue, but also other issues as well, and so on and so on, right? Yes, but we also had this model in the past that every request from the moment it hit our server or backend system till the moment that we sent the last byte was processed by a single thread, right? And when we had like a limited number of requests that was quite like easy or affordable or no-brainer, shall I say. But since we have these microservices, right, or micro-monoliths, it depends on your architecture, of course, then this model has been proven to be insufficient, because we had so many requests that we couldn't like handle it with operating system threads or native threads, because there weren't enough of them, right? So reactive was the answer for many of us, but who's been trying to debug or troubleshoot reactive code? Who would like to do that again? Just one guy, yeah. You're trolling, you're in the first row, you're trolling, obviously. Yes, exactly. So reactive is not debugging easy. Sorry, would you like to do that without IDE, which is gluing your... Okay, hands down. Nobody. Exactly. So this might not be trivial, right? And also, if you happen to use sometimes JavaScript or TypeScript, you might be familiar with this async await construct, right? So which is easy, like you do something, and then when it's ready, we continue, right? And so on. And we also didn't have anything like this in Java. And these pain points are getting addressed in latest Java versions, right? So there is this change. I guess you've heard about it. It came with different names in the past, right? Like fibers and whatnot. It seems the name that we're going to have is virtual threads as part of the umbrella project called LUM, right? Because, you know, LUMs and threads. And people are asking this question. Is it the biggest change, I mean, introduction of virtual threads since introduction of Lambda in Java 8? And there are two camps, and they don't fight each other because Java is a nice community, they're discussing, right? And some people say that no, it's not the biggest change since Lambda, and some say yes, it is the biggest change since Lambda, right? And some even say it's even bigger than Lambda. So it's the biggest change that Java has seen since Java 5 and in generics and whatnot, right? So see this, what might be facing soon may be more important than anything seen over last years happening to Java. All right, so what are these virtual threads, right? These are like second preview in Java 20, implementation of this JEP. I mean, these are clickable links. You can go and read the JEP, right, and try to understand it and play with it and so on. So this is the official reasons and like alternatives. I especially recommend you reading the alternatives, right? Why they didn't go for something else? And there are very nice reasons listed there. English is not my mother tongue. Yes. So what virtual threads are great for? Have you heard what they're great for? They're great. I/O. Someone said they're great for I/O. Yes, very nice. You get jellies. They're great for debugging because, surprise, surprise, they are threads, right? So they seem, or from certain angle, they basically feel like proper threads, easy to debug. They are very good for switching, right? When we have to switch between things we're doing, and they're great for waiting, for I/O, because I/O basically means waiting, right? You're calling your database, you're calling your file system, you're calling this external part of your micro monolith, right? And then it means I/O, and then it means waiting. So virtual threads are great for waiting because, fun fact, they don't wait. And how is this possible? We'll cover that in a minute. And they also reduce memory consumption as well, which is great. So the whole idea is to not reinvent the wheel, right? But to keep the threads model. I don't know if you know that, but like, it's not even a month ago that Java was celebrating its 28th birthday, or anniversary, shall I say, right? So it's a technology or ecosystem that lives over a quarter of a century, and really a lot of systems and a lot of businesses depend on it. So you can't easily change this, change that, release a new version or minor version, like break everything and so on, right? A lot of software built over these years relies on the concept of threads. So if you still have threads, and many, many developers used to working with threads, it can only be good. Hence, it's very nice that we are not reinventing this wheel. And virtual threads are covered by platform or OS threads under the hood, right? So let me use, we're in a fairly big city, I would say, at least for Polish standards. And do we still have traffic jams? Yes, there's still traffic jams, right? Very nice. So how does it work in a city, right? The space cannot inflate indefinitely, right? And there are cars and there's traffic and whatnot. And what we could do, let's say, after this lovely conference, it's the last day, you decided to go and hang out with your friends somewhere, and you decided to go to like, I don't know, a place, you know, and you love, like, across the city or something, and you could go with your own car, right? And then you park the car in the front of the place, and suddenly there's no more place on the streets or on the parking your friends or any other people who want to do that, right? Because your thread is waiting, your car is waiting when you're having this lovely dinner inside, or you're basically inside, right? Then we can go for this approach like car sharing or taxis. Whenever you have to transport yourself from place A to place B, you call a taxi or a Uber or Bolt or whatever, right? They take you to that place, and you are enjoying the dinner, having fun with your friends, and the resource that took you there is released and can serve other people, right? And this is the difference, basically, that virtual threads are this resource that you can use whenever you need, but whenever you're blocked waiting for I/O, so dinner is our I/O, then you release this resource, and this resource can be doing something else. So virtual threads are not blocking operating threads or system resources when they are waiting for I/O, unless you misuse them, and we'll cover that in a minute, right? They are cheaper to start. They unmount carrier threads when waiting for I/O, yes, as I said, and they only daemons with no more priority. I can show you in a code. Let me check. We should be able to see that in a code. Oh, this presentation mode. All right, where do I have it? I have a test, of course, because what else, right? Have you been to Venkat's keynote today? He said great words, right? If you start reviewing something and there are no tests, basically you stop reviewing in that very moment. I love this quote, right? And so you can also use tests to explore what's new in the frameworks you're trying to adapt, or in the language, right? What the features and whatnot. So this is what we're going to do. We're going to run the test, right? Okay, let's run it then. Okay, hold on. Let me. How do I shift 12? Yeah, I'm not used to presentation mode. Sorry. Fun fact: I've been an engineer for years, so I don't present that much. Yeah. So all tests passed. Very nice. So what are these tests? This is how we can start a virtual thread. Right? basically, this is just a thread. As you can see, we're keeping the model, right? And then, let me make it a bit, can you still see the code? Yeah, okay. So, whenever you try to stop virtual thread or suspend it or resume, it will throw you unsupported operation exception. And even IntelliJ is smart enough to tell you, don't do that, right? It was never a good idea to do that, let's be honest, right? Yeah, and whenever we want to set this thread to not be a daemon, to not be a daemon, to be like a regular thread that's blocking your execution or your flow, then it's going to throw illegal argument exception, meaning they don't want to stop being daemons. However it sounds. Okay, yeah, so they should only be daemons, and when they tell them be daemon, they, sure, why not? I still can be. I mean, see, this test has passed. And when you try to set a different priority, it sticks to normal priority. It doesn't move anywhere. It's still normal priority. And yeah, there are also like changes, like also other things that we are able to opt out from thread locals or inheritable thread locals. But since this is not going to be a thing in Java 21, let's skip it, okay? Because I guess you're not going to use it that long, because we have how many months like left? Just the summer. If between Java 21 and us, it's only the summer. How lovely. Okay, yes. And they allow this, going us back to this thread per request nicely, right? Because when you have a thread, virtual thread, handling your request, and whenever this thread has to wait for a database call or file system call or another microservice call, it will release the resource lying under the, or using it under the hood, right? The taxi will go and serve other people, and whenever the thread has to resume, it will come, and hopefully there will be enough taxis to get it there or keep processing. And it's also nice to like debug and troubleshoot, because they are just threads, right? And they improve scalability for asynchronous style of programmers, while still keeping this synchronous mindset, shall I say, right? And there is, if you have an old system or just a system, right? I mean, some people say if you just turn your eyes from a system for 2 weeks, it's already becoming a legacy, right? Yes. So there is no magic switch button or magic to push or switch to turn your threads you currently have into virtual threads. So there's no XX something, there's no D something, right? What you have to do, you have to go into your source code and basically in your source code say, I want this thread or thread pool to be virtual. This is how it works, right? So you have to touch your source code, and you can go for threads or thread of virtual, you put runnable and start, right, as you saw in the test. Or if you prefer to exchange y and dot for one extra character, you can start virtual thread right away, right? And for executors, this is how we do that. New virtual thread per task executor, and that already tells us something. New virtual thread per task, we'll come to that. And should you need a factory, this is how you create it. Right? I know it's early in the morning, I mean, for us, the IT vampires, right? But it's the third day of this lovely conference, and you might be tired. And if I could make a request to remember a single thing from this presentation, or the most important thing from this presentation, this is it. That virtual threads won't magically squeeze more juice out of your CPU or silicon. And I don't mean silicon, but silicon, which in Polish is krzem, okay? That's important, right? So it really depends on your domain. It really depends how you use them. It really depends if you're putting stress on your fork join pool or not. Because, fun fact, the company that's giving us the cars, right, in this metaphor, it's called fork join pool as we speak right now, right? There are concepts or work or basically ideas that we could provide our own thread pool, right, to have virtual threads. But as far as I'm aware today, it's not going to happen. It's not the case of Java 20, and it's not going to happen soon. But I may be wrong, right? Maybe they switch some gears. I don't know. So this is it. it really depends on your domain, how you use them, because they exist, the threads and virtual threads, they also exist in different spaces. There's kernel space, there's user space, there's switching, there are cache misses and whatnot. There are great presentations about these aspects of virtual threads by two lovely Italian people, Mario Fusco and I hope I won't misspell name, Francisco Negro. You look for them or YouTube for them, Fusco or Negro, right? Great content when you need to like profile or get like the performance insights for virtual threads. Really recommend that. I saw them live. Yes, so important thing to remember, virtual threads are not GC roots. If we are supposed to have many virtual threads, they can't be GC roots because then our GCs would crawl. And question is, how many virtual threads can we have, right? This part of experiment may blow. So again, let me apply the health and safety protocol. We never know, right? So how many, okay, in this machine, how many regular virtual threads I can create? Guesses, I have jellies. Who guesses the closest? 100 million, like I'm talking about regular threads right now. Okay, regular threads, good old-fashioned threads since Java forever. 2,000, 3,000, 10,000. Depends on memory and how many, yeah, and the setup and how much stack allocate. Yeah. This was the best answer. Jellies. I throw you catch, okay? Perfect catch. Very nice. I should have an experiment for this. Let me check. And this is like let's go here, right? Yes. So this is dummy code, right? You don't do that at home and you don't do that at production. It's stupid because instead of doing real work, I am using sleep, okay? And you don't, if you use sleep in your tests, in production code and even in tests, it means something somewhere went wrong, right? But this is not production code, this is not even test, this is demo, okay? So for demo, it's still okay-ish, okay? So I'm going to try to run 30,000 threads, right? And each of them will be blocked for 10 seconds. I create an executor, and for that many, I'll be blocking them for that long, and every 5,000 threads, we're going to report we have 5,000 threads, right? And how much it took and so on. And oopsies, no. We have to go with a new cached thread pool. Let me run this thing. And we shall be able to run, I hope, this 30,000 threads. Let's see. Yeah, 5, 10. Come on. Yes, we reached that, and now it's waiting also like for the time. Yeah. Let's stop here. Okay, now let's try 35,000 threads. And oops, it didn't work. And the answer is just as you have said. It goes to memory. Not enough space, right? There was not enough space, so I could like play with it, like maybe assign more memory than defaults and shrink the thread stack and whatnot. But I could push the limits, but there are still limits, right? And the question is, if I switch to virtual threads, how many I'll be able to run? Let's see if I can run 35,000. Come on. Okay. All at once. See, they even behave like a little different, right? So let's play it bold. Let's cut some corners because we have only 2 hours, not 3. Let's say 1 million. And maybe it will work, maybe it won't. Yes, apparently it's working. And I would say what was blocking us also as well was this output, you see? So I was able to create 1 million virtual threads, right? That tells you something. how many threads you can say. So who has the problem that within 14, let's make it 15 seconds, their system has to handle 1 million requests? Exactly. Such rich people aren't in this room, myself included, right? If you have this problem that you hit 1 million, that your system is hit by 1 million requests, you're not attending IT conferences, you're sailing in your yacht, right? That's the yacht problem. We don't have that problem, but should you have that problem, and I wish that you have this problem, each and every one of us, then virtual threads can help us in this regard, so we can create that many of them. But they mean more work for GC because they're user space, right? They live in HIP. They don't guarantee first CPU usage. They're greedy. And this is what you have to remember. So as like when you get into your taxi, right, till you live it, you're occupying the taxi. And the taxi driver won't tell you like, okay, you've been like riding enough, get out, it's time for another person. No. And this is what you have to keep in mind, right? And the corpo is called fork joint pool. So there's limited number of these underhood cars that driving you through the city, right? And it also depends on your parameters, on your hardware, how you like set up your JDK and whatnot. But there's again like a limit of the proper underhood threads that are handling virtual threads, right? So be mindful about this. It also means like cache misses, right? Because it might be like different thread living in assigned to a different core, right? And then it means that we'll have to reach for like further and further away, right? To get the data for like from the cache, right? And okay, so these are lovely. We can create a lot of them. What not to do with these virtual threads? You don't reuse them. You remember that executor? It said new thread per task. So whenever you have to do something with a virtual thread, you create a new one, period, because they're so cheap and easy to create. You don't pull them, therefore. There is this postman approach to handle back pressure that we create a thread pool of, let's say, 10 threads, 20 threads, whatever threads, right? Just toss a number, right? And then NQ tasks have to wait, right? And you don't do that with virtual threads. You don't pull them. You just create as many as you need. You need to have different ways to handle pressure, okay? Not just pulling the threads. And what you also don't want to go is to pin the threads. And let's say you went to this lovely place with your friends, and turns out this lovely place is a bank, right? And you're robbing the bank. So what do you tell the driver? Like in the good gangster movies, keep the engine running, right? And when you do this thing, when you say keep the engine running, the taxi can't go and ride other people, right? And how do you say in Java, keep the engine running? There are two ways to say that in Java. First, do a native call, because when you're doing a native call, then obviously Java doesn't know, like, so it means like the engine should be running. And as of now, as far as I can tell, there's also the other way to say that. A call, like make this or leave this taxi in a synchronized method or block. This also means that the car will be pinned, or virtual thread will be pinned, right? And you don't want to do that, basically, because then it can't go and serve other people, right? So basically, don't call I/O or these waiting operations inside synchronous methods or blocks, right? Else you're basically derailing the whole virtual threads experience, I shall say. And how can you detect that? I have entries about like 2 methods how we can detect that with Java flight recorder events and this tracing pin threads on my blog post, which is softwaregarden.dev, mind you. And I'm going to show you one of them. So, who has microservice? Yes, we have microservices, right? As part of our solution. And let's say we have like a greeter microservice, and this microservice is using HTTP client, which is available since Java 11, and this HTTP client is going to make a call to a like Nginx server, right, to just call a page and do like hello and what's happening inside there, right? And it's like this. And you want to make sure that when you switch to virtual threads here, that these are not made from like regular threads, but virtual threads, that you won't be pinning these threads, right, in this call. So how can you ensure that, right? You can make the change, deploy to production, and keep your fingers crossed, right? Or you can be a proper scientist / engineer, and you can test it before you ship it, right? And then you can go like this. You can employ toxiproxy. And what toxiproxy does is a great piece of technology, acts as a proxy, and as the name implies, you can intoxicate this network trip, right? So what we're going to do in experiment is that we're going to intoxicate this atmosphere, this core, to make it last at least 500 milliseconds as a latency, plus minus 50 as a jitter, right? So this is what we're going to do. And no big surprise, if you take a look at the stickers on my laptop, we're going to use for that test containers, because what else, right? Yes, so we're going to deploy our product or our system in this container, and then we're going to use toxiproxy in another container and run nginx in yet another container, right? Yes, so let me find this thing. May I switch off this presentation mode? Sorry, I'm not used to it. Let's see. If you want me to keep it, just let me know. Right, but it's also like you don't. Who's working like every day with presentation mode? Exactly. So it feels odd when I'm showing it in presentation mode, right? Yes. All right. So where are we? Yes, I have this greeting container. See, so I'm like getting a greeting, and there's a client, HTTP client. It sends a request, and I see which attempt it was, like what was the body, and so on and so on. And it should be tested somewhere, and it's this thing. Yes. So I have index.html file, which is here, right? This is the file. I'm creating nginx. I'm creating two containers. I'm creating nginx container, and I'm copying a file to this container, right? And then I wait for this file to be ready. I mean the whole container, right? And oh my gosh, sorry, I took a look at the timer. Yes, and then we also create toxiproxy container, right, to act as this toxic proxy in front of, yes, and then I'm starting both of them in parallel so I don't waste time, yes, and here is how I say add some latency and add some jitter, and then I'm putting the jar I created using Maven to this Java container, and I want JWeb server just to block the calls. I'm starting the container, and then I'm going to tell my client to call the proxy, which will take us to this original nginx thingy, and this is how I test if my thing is not pinning the virtual threads, right? I'm setting JDK trace pin threads. It shouldn't have space in here, right? And this is the jar, and hopefully it should exit with 0. And it shouldn't contain the onPinned, because this is what it does. When you go for this flag, it will give you exact stack trace where you are pinning your virtual threads, basically telling the cars or the taxi drivers keep the engine running, right? Let's see if this thing works. How am I? How do I? MVN Maven test. Yeah, let's keep test and let's run test. Then let's see if it works. Yeah, so we see test containers in action. Yeah. There were already 2 talks in the workshop, so I guess if you're more intrigued how this works, just look for another video if you're watching us on YouTube. And if you wanted to attend these talks, sorry, you missed your chance. Yeah, and this is, you can see the output, right? So we created 20 calls and attempts, and there was like what was from the body and everything. So the test was green. We didn't pin a single virtual thread. However, let me now say that we're going to make this call to this HTTP client from a synchronized method, right? And now again, I need to package the thing without test, because else the test won't like chicken egg problem, right? And then let me test it, and we'll see what happens now. Yes, we started toxiproxy, we're starting Java. Oh, and the test didn't pass this time, right? Which means we were pinning at least one virtual thread, and this is it, right? You see that this is the output, and it tells you exactly there was this something. Maybe I should run it from here. Maybe it would be easier for us to analyze the results, how it works. Not from this CI mode, but let's say proper development experience. Yes, should not be. Oh, it's not much better. Yeah, but it expected not a string containing unpinned, right? And I'm asking if the thread is virtual and whatnot. And as you can see, we sometimes some responses start saying that they are parking or pinning virtual thread, right, and so on and so on. Maybe I should go. Maybe it would be easier like this. Sorry, see demos like sometimes they not here. Result. Let's stop here. Let's stop here. That should be the best way to stop it. This is the beauty of running integration tests from your machine, right? So instead of trying to figure out from this build log what went wrong, you can run it on your machine, put a breakpoint, and let's see this result of standard output. All right, so I have the result here, right, and I have standard output, or I have the standard error. See. And this is it. Now it's nice, and it says us that something. There's connection exception. There's blah, 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 cost, and it should have somewhere like this on. Sorry, it was standard output, right? Here. Yeah. And it should tell us somewhere. Is there like on pinned? Yes, on pinned, and so on, right? And it should also, like, it tells us here, see exactly that in greeting obtainer in line 27, I am saying keep the engine running. So let me go to greeting obtainer line 27. Yes, see here, exactly, because it's inside synchronized block, right? So I would suggest if you want to switch your system to virtual threads, right? Because this is a great piece of technology. I shall even say, we can like, in a few following seconds in the recording, it's a kick-ass piece of technology, right? It may improve the performance of our systems or how we handle our systems in a great way. However, this tool can also be derailing your solution if you're misusing it. And this is how you shouldn't be misusing it, right? You shouldn't be making a blocking call from inside synchronized thingy, right? Because virtually, like you're like removing taxis from your city traffic, right? And this is a way to test it if you don't have any other approach. Just put your thing inside a container, right? Like do whatever the application normally does, and if it tells you somewhere that it's pinned, then you know you're misusing it. And then instead of using synchronized, you have to go and start using, I don't know, like whatever else, like semaphores and stuff like this, and so on and so on. This is how we shall be dealing with such things, right? If you want to redo this experiment on your own, there's a blog post entry on this. Yes. Structured concurrency. Another great thing that's happening. So it's about better idioms for multi-threaded code, right? And help eliminating thread leak and cancellation delays. And without touching current concurrency stuff, right? So whatever there is, like threads and completable futures and futures and whatnot, stays. We just have something new to use it to make our life as developers easier, right? And our users also should be less frustrated because it means we'll be able to produce less bugs. Yes, and right now we're not replacing interruption with cancellation. So interruption is part of the Java thread model because it relies on monitors and whatnot, right? So this is science, apparently. And it looks like this. And again, let me maybe switch to code because code is usually better. Where shall I have it? Like here. No, not this thing. Sorry, not this thing. Not this thing here. Oopsies, I didn't roll back the code, so let me roll back the code because it spoils. Spoiler alert. No, it's okay. Yeah. So we have two services, name service and score service, right? And you want to have this scoreboard. So someone calls your service, and your service has to do the following. It has to call one service to get the ID and the name of a user, right? And it has to call the other service to get ID of the user and the current score. Because, I don't know, they play chess or whatever other game, right? There's like a tournament. And of course, then you have to sort of join or merge these results by user ID, right? And present the result being the name of the user, of the player, and current score, right? This is what our system is doing. So we have this sequential scoreboard, and it, as you can see, it does this thing. It calls the name service, it calls the score service, and then it combines the results and presents them, right? And let me run the thing. Oh, I hope it will work. Yes. So it takes more or less 2 seconds. It seems that Joe has 100, Susan 100, and Christoph has 300. So he's winning. Lucky him. Right. And it takes 2 seconds. And your manager / product owner comes and says, look, it takes 2 seconds. What can we do to make it take less, to be it faster, shorter, better, superior, whatnot? What can we do when you look at such code? Parallel, exactly. We can call them in parallel. So we can go for, let's say we start going to use futures, right? And then we turn into this. We start new executors, right? And we submit call to name service, call service right now, and yeah. So how long is it going to take? You don't know, and I know because I wrote this pesky demo code. Don't do that at home. It does the following. It sleeps for 1 second. Right, and so does the score service. It also sleeps for 1 second, and you don't do that, right, at home, right? So, given this knowledge, how long do you think this whole service call will take? More or less 1 second. Yeah, let's do that. And now, yeah, 1 second. 1 second. Very nice. And now let's say that there's been like some construction works or something, right? And they hit the fiber optics and whatnot, and now we don't have the connectivity to our get name service, so it's going to be oopsies, right? Before even sleeping. And now the question is, how long will it take to fail? 1 second. Who said 1 second? You said 1 second. Okay. Any other guesses or bets? Some say we'll wait forever. Time out. Okay, let's see. It takes 1 second. Very well. I throw you catch. Sorry, I missed. It was my miss. Sorry. But almost, like nobody was hurt. Great. Yeah, it takes 1 second. Why it takes 1 second? Because when this thing crashes, right, and we wait here and we wait here, I mean, this thing is waiting 1 second on its own, regardless if this thing has failed or not. That's the problem. So what we could do, we could make them like a cross-calling each other or subscribe to each other. So when one thing fails, the other thing would know there's no reason for you to wait, right? And with 2 futures, it's doable, sort of, right? Would you like to do the same with 4 futures? 7. Exactly. Nobody wants to do that. So maybe, just maybe, we can go for structured concurrency, my friends, and do something like this. See, the code looks quite similar, I should say. Instead of just executors, we're going to use structured task scope, which says shut down on failure. Right? And we do see, we again call these 2 services, then we have to join and throw if any of them failed, right? So I want to like propagate this failure, right? And if it's okay, then I get the results and I combine them, pretty much like here. And now the question is, how long will it take? Close to 0, you say. Let's see. Yes, it still fails, but at least faster, right? Exactly. But so what it gives us this cancellation for free. We don't have to subscribe these tasks to each other, right? If one fails and if we are in the shutdown or failure mode, it means the others will be notified. And in this oversimplified example, we have just 2 tasks. But imagine we have 7. And then the gain is obvious, right? Exactly. And all right, let me revert this thingy. And there are two things you shouldn't be doing with the scope concurrency. Come on. Let's try to run it now. And okay, I don't have this incubator module. Okay, I forgot to apply my own advice, which is this thing. We have to add here, and let's click here and modify run configuration, and it's then Alt V. See, this is proper demo. This is live coding. I'm not cheating you. Let's see if it works now. Yes. See, I had to enable incubator module, right? Just like -- enable preview. And now it says it took 1 second, right? But maybe I was misusing it, or maybe I wasn't. Yeah, no, it threw an exception. It's wrong. It's a good thing, but it's only this exception that went wrong. See, you can call fork only from this scope or from fork of the fork, meaning we can go deeper, right? But you can't pass this scope to some other thread, right, which doesn't own this scope, to run its forks. That's illegal. That's nada, right? And okay, so let's say we don't do that. And what happens if we don't join? If we forget to join this scope before here? It says it throws us an exception. Task has not completed, right? And it's captured here in main here. See, so it printed us. I can even put a breakpoint. I hope. Let's see. Let's do live demo. See, it throws us an exception, and the exception is illegal state exception. Task has not completed. I would say they could make this exception better. They could say, you have forgotten to call scope join dummy. That would be better, right? So whenever you use scope concurrency and you see task has not completed, it means you have forgotten to join to wait for it, right? And this is it when it comes to scope concurrency. It's free cancellation from this 3, right? Within this tree, not 3, typo, sorry. And there are 2 task scope by default. So we've been using shutdown on failure, which means whenever one of them dies, everybody dies, but we can go for a different scenario. For example, let's say you have cache A, cache B, and a database, right? And we want to get username of a certain user ID. And let's assume people don't change their user names so often, right? So then you don't care which cache responds you first, or is it like cache A or B or a database? You just want to hear one response from anyone, right? And then whoever is first, then you tell other tasks, don't bother, don't worry, I have my answer, like it's already success. Then you go for shutdown on success, right? And if you need something else, let's say I need 2 responses out of 3, let's say, or something like, I don't know, something fancy, you can implement your own structured task scope. And don't forget to join or join until. You can put a timeout there as well. Very nice. Scope values, last part of this concurrency thingy. Lovely. We still have more than an hour. I love these deep dives. We're not going to make any breaks. Sorry, at least not officially. I hope you can stay with me for 1 hour more. If you can't, because you desperately need coffee, because yesterday was a hell of a party. Coffee is there, right, just across the door. You can grab a coffee and come back, or whatnot. We're civilized people, right? We can manage ourselves, right? We can manage ourselves, right? You can take this message to your companies. Yes. In a way, these are one-way immutable thread locals, right? This is the shortest description what scope values are, but this is like, it's cheating a bit, right? And they have bounded lifetime, and this boundary is visible in the code, which means reasoning about these immutable thread locals easier. Question, who has been debugging a code for like 2 weeks, or maybe even longer, to only discover that one thread doesn't kill or clean its thread local. So when this thread is, I'm still talking, but people are already raising hands. I love this. I don't have to finish. You've already been there. You know the pain, right? Of not, and it's like, I feel you. I can relate. Exactly. So one thread didn't clean thread local, and then there was another thread, and suddenly it had admin privileges, or people saw like account statements from other people because we didn't clean the thread locals or whatnot, right? And what these two are supposed to give us as outcome is simplified reasoning about the code, so then it should be basically visible in code, right? So even static analysis could help us, and improve performance, because it's one way and it's immutable. Because, fun fact, if you create 1 million virtual threads, like we did some time ago on this machine of mine, and then each and every thread is given its own thread local, do you think the memory will be happy? Exactly. So maybe if the thing is immutable, right, and we use it within, let's say, this structured concurrency, we need to create just one object, right? And then every thread or task below can use it, right? Just single copy. Okay, so thread locals don't change. Like they still needed, there are valid use cases, and if you find scope values not enough, you can still fall back to thread locals, right? And they don't even get deprecated because they're really like proper piece of technology, only maybe more difficult to reason about, right? Or handle. And yeah, having them in millions of threads might be problematic. Let's see the source code. The code is far better. Let me ask you, any Star Trek fans in the room? Kapla! I love you. Please come. I won't throw that far. Yes, please come. Yes. Yes, live long and prosper. Yes. Yeah. No, yeah, may the force be with you. Yeah, of course. Yeah. So, scope values. We have, this is a starship, right? This is a starship. And a fun fact, it's going to be Voyager, right? So we've been thrown to the other edge of the galaxy, and now we have to make our way home, right? Anyway. And let's say we have a concept of clearance level. So basically, you are able to do certain things on the spaceship, right? But it depends on how much powers do you have, so to say, right? So see, maybe I should show this slide first, right? This is a simplified version. So we create a scope value here, right? New instance we create, pretty much like thread locals, quite similar. And then we say where. Right? Where, and this is the scope value, where, and this we assign to this scope value like certain value, I mean, as the name implies, right? And then we run, or we call, I mean, run is for void and call is when you expect the result, certain things. And then inside, when you call for this or ask for this clearance level to give its value, within this run, because of this where, is going to serve us this thing, right? And we can deepen that. Right? We can do that the Matryoshka way. So you can go deeper and deeper and deeper, right? And yeah, so we are doing some stuff on Voyager, and what this stuff is. We can turn the lights on, we can locate a crew member, and we can also block bridge controls. And so we can turn the lights, like everyone can turn the lights, even prisoners in a brig can say turn lights off or on, because we are civilized people. We are not torturing someone with light, for example, right? Then we can locate crew members if we have clearance level at least of 2. See? So let's say visitors cannot locate crew members. You have to be crew member, and that means you get like clearance level at least 2, right? Easy. And then to block bridge controls, you have to be captain or acting captain. Right, at least 10. It's oversimplified. It's integer, but it's to give us or tell us the story, right? And let's run this code. Let's run this code. Yes, again, maybe this thing. Sorry. Again, sorry. Somehow, I mean, from the previous runs, it didn't last. So let's go again. See, it's hot, cool stuff. It's not production ready. And I'm already showing it to you. That. How cool. Yes. So, we have assigned our character in this little game a clearance level of 7, right? And we are more or less here, right? And this person is able to turn lights on. This person is not able to block bridge controls, right? And is able to locate where the commander Tuvok is, apparently on deck 5, right? And then you naughty person, will put you in jail or in brig, right? And then we put the level for prisoner, level of prisoner as the clearance level, right? And then we can say what you can do now. And turns out we can't do anything but turn the lights on and off, right, as a prisoner. And see, this is the scope of this being in jail situation. Right, this is the where and the run. And when this finishes, I'm gaining again my clearance level 7. That's why it's scoped value, right? It gets deeper and deeper, and when it ends, you get what it was there at the beginning, right? And I really encourage you to do it, not just call get, because when you call get, you'll do the same pesky thing as with optional get, right? What you should be doing, or what we should be doing, and I would say, is call this, so this might not be the best way, right? Let's call this or else, or let's check if it's bound as well, right? Because it might have not been assigned, and therefore you get like, I don't know, NPE or something like else, right? Something like that, and that won't be a nice thing. So see, this is a way to basically handle such ways, and this is structured task scope again, right? And it's using virtual threads under the hood, so we can see this concurrency story evolves, right? And we'll have new idioms, not just powerful horses, like working horses as the virtual threads, but also like stuff on top of it. So in a way, we get our new async await. I'm not sure if it's maybe, I don't work for Oracle or anyone else for that matter, so I can say things. I'm not sure if it's not too verbose with this scope join and everything, right? But on the other hand, please keep in mind that this is Java is, some call it Jabol, right? Or Jabol in Polish. So it's like Java and COBOL. It's old, but it's still alive. It's getting bigger, more adopted, and kicking, right? So we can't just toss new keywords or new paradigms and something. So please keep that in mind when you say, yeah, it's like bloated, too much code or whatever, right? For me. Yes, so scope values. Work nicely with structured concurrency. You call run or call, depending if you have like expect a result or not, right? And where can be nested. You can go deeper and deeper and deeper, right? So for example, like in real world scenario, you're handling in a scoped concurrency, you, for example, set like let's say this was a proper HTTP request, and you set the access level, right? And they need certain access level to, for example, create certain queries to database, right, or file system. But when you log something, the logger or logging framework doesn't need to have these privileges, right? So we can nest where and basically void all privileges to make sure nothing is leaking there, so we don't have log4shell, for example. Okay. It's been 1 hour, right? So we continue, and now we're jumping to a new chapter, which is processing data. And I'm really, really, really happy that yesterday in the room across the corridor there was a whole hour or like a proper session given by Piotr and Hanno, and they were talking about switches and whatnot, the story of Java and so on. So therefore, it takes the burden from me, so I can do it in a slightly simplified version. There's a question. Yeah. I can't hear the question. I'm sorry, I still can't hear it. There's a noise from the corridor. Yeah, sorry. And we don't have, unfortunately, we don't have a spare microphone. I would toss it. Yeah. Yeah. The question is, if we have real and virtual threads, how system will split the resources? So there is no magic. Let's go back to the point that virtual threads are carried by fork join pool as of now, right? And this is it. So in this regard, if you have a task already, someone closed the door. How lovely! So if you have fork join, I could like rewrite your question like this: if you have regular threads and fork join pull tasks, how system splits the resources, right? This is the question you're asking virtually, and so like another question. What about virtual threads and class loaders? It's a good question. I'm not sure what to tell you. I mean, let me like ask you like what about them? I don't think so. The question was, can we set a class loader for virtual thread, right? So virtual thread feels like a virtual thread, but how they are really implemented is that they are continuations, right? So if you're into concurrency and you know this like a pattern of continuations, these are continuations basically being switched between or among like virtual threads doing the actual carrying, right? So we don't see them in stack traces and whatnot, but they're there, right? Bring it on. Mm-hmm. 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 Yeah, so the question is, okay, when the waiting takes place, because there was like a blocking operation, like network code, for example, and it finishes and we want to continue, is it the same virtual thread or what is it? It's the same virtual thread. Virtual thread is the same because this is like how you process, this is the threading model. However, we are not we're not aware like which real or like native thread will carry this virtual thread. That's why I said it can mean cache misses and so on, right? So whoever will be able to like whichever thread from the pool that's giving a ride to these virtual threads will be ready. We'll pick your virtual thread and take it to another like carry on. In this restaurant situation, it would mean we're done with the dinner, right? And now we want to go home, and you call for a taxi, and you don't know what taxi driver will come. The first available, basically, right? Yeah. Yeah, but it's still taxi. It's still taxi. Yes. Any more questions? It's this question. The question is, basically, what about reactive approach? I like to avoid this question because it's not only a technical question, it's in a sense, it's also like, please excuse me, it's this political question, right? So reactive approach or reactive way of handling things was born also because of these issues with blocking and not enough OS threads or native threads and so on. True. But reactive is more than just that. It's also like handling the code, this like declarative / functional style and whatnot, right? So will it kill it or not? I don't know. We'll see, right? For sure, I expect that if going reactive was motivated for you mostly because of this blocking, I guess Loom will make it way simpler for a lot of people, right? A lot of companies and systems, right? However, if someone relies on these other benefits of reactive approach, they will keep doing it, right? And how it will turn out, I don't know. We'll meet each other within a few years and we'll see. I don't know. I mean, how can I know? I'm just a software engineer. Any more questions to the concurrency thingy? I'll be still hanging around for like a few hours after the conversation so we can grab me, right? So let's go to this new chapter, processing data. Yes. So there is record. Who's using records? I mean, Java 11 people I know to use records. Okay, but quite a few people are using records. So quick reminder, there are standard data carrier now. Standard as in they are not gentleman agreement like Java beans, right? But they are specified in Java language specification and whatnot. They are transparent, they're immutable, and now they're for carrying data, right? And current syntax of Java might not be easy to handle data first flows, basically. You know this thing, right? If it's Java 16, as far as I can tell, right? So even if we identify our object as being an event, then we have to find, like, if some field in this event has a value compared to this, like, then we do something or we do something else. Yes. And then we can go for a pattern matching for switch, which is fourth feature in Java 20. And fun fact, good old switch remains the same. It should have exactly the same behavior and semantics, and nothing should change. If you compile your code using Java 17 and beyond, and suddenly your switch behaves in a different way, it means you found a bug and you report it to OpenJDK. I don't think you'll find it, but in case you do, this is what you should do, right? Yes. And this is how it may look like. And it doesn't have colors because this JavaScript coloring plugin is not, you know, handling new changes to Java. And this is this new switch in a nutshell. So I can see, as you can see, I have an object. So now I'm not switching just for primitive types, enums, or strings. I can switch for objects, right? And then I switch, and then I don't have to guard this switch with if null, then do something else, I will face null pointer exception. Now I can add a case for null as well, right? And then I can do something. I can throw another exception, right? Then I can switch for certain classes, for example, and I can even put so-called guards. So whenever it's like more than Java 17, I can say it's Java 17, right, or above, or then I can react by how, and I can still have like default thingy, right? So this is how it may look, much more concise. Now try to express the same using old switches, using if blocks and whatnot. It might not make into this slide, right? And it's not particularly nasty or picky example, right? Okay, so switch can be now more null friendly, as we've seen, and handles objects, not just these good old switchy thingies. So-called dominant cases aren't allowed by a compiler. We'll get to that. And cases can contain guards. As you've seen, it had this when at least 17, right? This is a guard case. And sealed classes or interfaces don't need default. I mean, when you exhaust all possible branches, you don't have to go for default. And pattern matching doesn't work with primitives yet. I mean, we're talking about Java 19 and 20, right? In the future, there are plans, as we could have seen yesterday, to go for primitives with guards as well. And it applies to both switch expressions and switch instruction. The difference between them, since Java 14, is that switch instruction is like what we had from Java 5 or 7, right? So you rely on side effects, whereas switch expression gives you a value, basically, right? So you can assign something, in a way it's similar to a function that returns something, like, right? So basically instructions are always sort of void, whereas the other things return you something, these expressions. And pattern matching doesn't allow fall through because, fun fact, how could it do that, right? It doesn't make sense. Yeah, so let me show you that. Let me show you that. Where is it? Switch pattern matching. Yes. So let me run this code and we'll cover it briefly, maybe without going too many details because there was this lovely session yesterday. Yeah. So switch instruction keeps working the same time, right? As you can see. And when I put there a null, I mean, even IntelliJ is clever to tell me it won't work, right? But yes, then it basically explodes like it used to. So there's no change, and it should say expressions here. Sorry. Yeah. So this is 7 and 14. You see with these things. Oh, sorry, that was instructions. Oh, sorry, it wasn't that bad. Here, let me roll this back. See? Live coding. Okay. We can handle nulls now. As you can see, we can say case null, even if this old Java 7 style, right? So we don't have to go for this arrow style. You can still keep it your own style. It became null friendly, and now you can also have case null and default combined. In the previous preview releases, we could put them like in different order. Now it's only these two can be done together and in exactly this order, right? Yes, so we can have like case null, as you can see, or we start switching over an objects right now. So whenever it's string, we say you're a string. Yes, hello, or hallo, spricht jemand Deutsch hier? Grüße. Aber, yeah, okay. Yeah, so you're an integer, you're a long. We can also assert if this is, or check if this is an array, right? And then we say use something else, right? Because you were an instant, for example. And then, yes, what are these dominant cases? See, if I go for this thing, it doesn't, I mean, IntelliJ is showing it's not going to work, and I can't even compile it. It yells at me because this case label is dominated by a preceding case label. Why is that? Because string is serializable, right? So it makes sense if it's going from top to the bottom, right, in this exact linear order, right? But the complexity is not linear; it's constant because it's jumping there right now. I mean, instantly. Then if it's here, it can't go for string as well, right? That's why it's not allowed this way. However, I can go like this, right? Because now string doesn't dominate serializable. There might be other serializables as well. I mean, this feels natural. We don't have to like discuss it like a lot. Okay. Sorry? Like in catch, exactly. Like this is like a very good metaphor, I'd say. To like in catch. Yeah, makes perfect sense. And now we have, yeah, if we had this code in Java 16, this is actually my piece of actual demo of Java 16. In Java, since Java 17 or like 19 exactly, because previously we had ampersand, now we have when. We can express ourselves in such a way. So if it's a string and it has at least 3 characters, right, and it will produce us something like this. You're a string, at least 3 characters. Then it's a positive integer or a long that has at least 2 digits, right? Or it's an array starting with 5.0. By the way, you don't do that. Right? You don't compare floating point types like this, right? This is bad code demo only. So don't quote me in your, this is fine because I saw it in presentation. And then it can be something else, right? And yeah, the dominant cases, we've seen that, of course. And yeah, we have this. If you have sealed classes, I was covering that, I guess, a year ago. We can have like final class or a record or non-sealed class, but this thing basically can be extended by only these 3 classes, right? Then when we describe this thing, as you can see, I don't need the default. It's even grayed out, right? Because it's not going to be used. There's no chance to use it. So this is one of the properties of sealed classes, right? You might be using them, right? Very nice for your events, because you don't have to handle this with default or do this if else, and at the very end, else, right? It doesn't make sense, right? Unfortunately, it doesn't work with primitives, right? See, if I want to go like this is Google switch, and this doesn't work as of yet. It might be working like this in the future, but for now it doesn't work like this with primitive types. Of course, I can go for autoboxing, but I'm not sure if you want to go for autoboxing, if it's like your core path, because, performance penalty. I mean, if it bothers you. And we can also, use switch instructions, right? Yes, and handle patterns too. But as you can see, I can't allow to have fall through, because if I get rid of this return or this break, it also like makes sense with like catching these exceptions, right? If it matched FC and assigned it here, what does it mean to jump here, right? What it mean like then this FC alias, it's gone, it's not visible here, and the R is not bound, right? So that's why I have to go for returns or breaks, and of course it doesn't make much use to have a break or return here, right? I mean, this does not work, so we are not going to have break. Yeah. So this is how it works, right? And record patterns, second preview feature, is this. It's decomposing, right? Anyone doing Scala? A few brave souls. Okay, souls, sorry. Yes, very nice. So you're familiar with case classes or unapply, right? So basically, for you, short version of this, we sort of have automatic unapply now for records, but for records only, right? So yes, whenever we have a value or a complex type, we can go and nest them like this, like value and this. Actually, let's switch to code. I mean, code's always better, isn't it? Where am I? Yes, here. Oh, yes, to that previous point. It's not me. It was Mitya from Bulgaria who came to this. When you have to Dmitry Alexandrovich have when and so on, you can have something like this. Okay, without this default, you can say like when. Crazy. Okay. Yes, he's a very creative guy. I like him. Yes. Yeah. Okay. Okay. Back. Piotr, come on. Back to the. Yes. Okay. Oh shoot. Here. Come on. Okay, we are in. Yes. So I have. Is this the thing? Yes. So I have a value. I have complex, right? As you can see, there are records, and I have like the generic complex with like an n, right? And when I run this code, come on, because in code we trust. Very nice, yeah. So it says I got the value because it randoms the thing, it gives me something, and that thing can be even like a value with a random double, or can be complex of two random values. I mean, if you don't know what a complex number is, it's basically a number that you can do a square root of -1 and it still works, right? Basically, it's like the closest thing you can think of is like a point with 2 dimensions, like a plane point with like x and y, something like this, right? Like calculus, if you don't have like a heavy background in mathematics. Okay, yes, yeah. Let's rerun the thing. I got the value. I got the complex, right? And now, as you can see, I can go something like this. If this S something is instance of, see, I was also impacted by Scala right then, like with these short names. If it's value, then I don't have to go here and say like instance of value, and I don't have to alias value as good times and call v dot value, right? But I can use this record pattern, so I can decompose it here, like do the opposite of calling the constructor, right? I can deconstruct this object. Right? And then I have v here. I can go for this complex value r and I, and then I still call this r value and I value, or I can say, I can like, give me more, go deeper, and then I can just call this r and I, right? And let's say, in this very example, I don't care about the imaginary part, right? Let's say some thing. Come on. Thing. Yes, thank you. Right, so then I would like see this I is ignored, so I could say like var thing or var ignore, like ignore, but I have to say something here, right? Even if it's here, like here, right? And in future Java versions, if I'm not mistaken, starting Java 21, as a preview feature, we'll be able to say this. That's why a few versions back, we were not allowed to use single underscore, right? And in Java 21, starting in autumn, we'll be able to say something like this, like, I don't care about the rest, just match part of it, right? But this is something of the future. Right now we have something like this, right? And yeah, this thing is doing extensive, like, or as much as it can, type analysis of what's happening there. And as you can see, I'm not allowed to do this thing and this thing at the same time. Why? Because, fun fact, dominant cases, right? So this case is actually the same case. It dominates it. So I can go one or another. Yeah, makes sense, right? So I was cheating a bit because it seems very complex. It is not. Yes. Yeah. So this is it basically. And then I won't bother you. I guess you can play this code on your own. It also like shows that you might want to go for sealed classes and interfaces, because then it improves reasoning as well, right? With the generic types and whatnot. But it was like also covered yesterday, and I guess it didn't change that much since Java, like a previous release. Right, so let's skip this part because we might be willing to spend it on something else. Yes, so they allow deconstructing records, and for now records only, right? And with nesting, as you have witnessed. No other types for now, and it works with ifs and switches, as you also saw, I believe. So it's and if we miss that, let me show you that again. So see, I was doing that in ifs, right? And I can also do that in switches. So whatever works for you, you can use it. And let's go for the last big chapter of today's talk, which is calling native stuff. Who's using Sun Miscan Save, or who has been using Sun Miscan Save? Yeah, who's been using Spring like 5 years ago? Yeah, why didn't you raise hand before? Kidding. It was not only Spring. Everyone was to be blamed. Really, it was there. It was yelling at us. I'm unsafe. So what? Yeah. So everyone was using Sun Miscan Save, and then we had to pay the penalty of this, right? And these poor souls over there who's still using Java 8, I guess they're still paying this price. Right? Sorry. Yeah, and it has to be safe for time, range, and threads who can interact with native stuff, right? It can be tedious because you have to create these stubs, these .h files. You have to read these .h files, then you have to compile them, and then you have to like keep everything working, and you have to be like efficient in C and in Java to actually do this stuff. It's tedious, right? And we would also love it to be limited or safe, sort of like. So currently it's limited like byte buffer. If I'm not mistaken, you can address sort of like 2 gigs of memory, like 2 gigabytes. Because fun fact, the index ends, right? So you're not allowed to go for 3 gigs because there is not enough like numbers to index it, and it could be also slow, right? So we want the performance of the new native thing to be at least on par with Java native invocations, right? And hopefully better. So, do you know these soap operas? Like Bold and Beautiful, right? Or in Polish, it's Klan, right? And you know that it takes like for them like two weeks to air this single journey, right, across the town, right? Because it takes so much time. So in a way, this story also takes a lot of time, because it seems innocent, like it's second preview feature, right? But parts of it have been in preview for like 4 previous versions. So it's like 6th release we see it in preview or as incubating module. And will continue in the future. But I think it's good. Why is it good? Because instead of getting another .get, which will create more bugs, right? We will get, I hear you laughing, okay. Someone has been there. Yes. The creators, the big brains behind Java want to really make it as safe, as smooth, and as robust as possible. And that's why it takes so many iterations. And another train is leaving from the station every half a year, and it's not sent there as a standard feature. I really don't complain. I prefer it this way than to have something to call native stuff for another quarter of century, which isn't that well thought of, right? or through. Okay, so what are the building blocks of foreign memory access and API? We have memory segment, so it represents the region of memory. And fun fact, memory in your computers, how many dimensions memory in our computers have? You can be off by one. One dimension, yes, who said that? Exactly, there's one dimension. Memory is linear. They show it like a big table, right? Because this is how RAM chips look like. But it's computers or CPUs see as in linear, just as architects see databases as big cylinders, right? Which is also not true. Yeah, so you have this memory address, and it's like sort of like one number, right? And we have memory layout. So who's been doing like C or Go? Or maybe you just have heard of structures or structs, right? So they sort of like very, like anemic objects, which means only data, no methods or functions or no behavior in them, right? So you can say, for example, I have this structure, and this structure consists of 3 fields, and the first field is a character, the second field is like, for example, long, and the third field is another structure which has its own layout and so on. So instead, and when you have to, like in this memory segment, when you need to access second field or third structure being kept in that array, instead of doing the math on the back of an envelope where you really have to put the pointer or where to set the index to read it from this sort of big byte array, right? You just say second field of the third element. And because we have a layout, this whole FMAA thing is able to do this math for us, right? And there's arena and segment scope, providing boundaries for time and thread, and it plays really nice with threads, with resources, and var handles can be used to store and fetch that. I believe Jarek was talking about var handles here, like in this very room, like 2 days ago. Yes, yeah. So this is like short example how it might look like. So you see we have memory layout, and I say, very oversimplified example, I want to have 10 elements which are of Java ints, right? And then I'm opening an arena, and it's confined, meaning only the thread who created this arena is able to play with this arena, like no other players, right? It's not open, it's confined. And then I have this memory segment, and I allocate it like in native memory, meaning off heap, meaning the garbage collector won't play with that or mess with that, right? And I say I want it to be of this layout and in the scope of this arena. And then I can, for example, iterate over this layout, right? And set elements at this segment using, for example, this set at index or get at index, right? Okay. Yes, so let me quickly show you a demo. Right. Come on. This thing. Yes. So for same thread, let's see if it runs. Maybe I also have to add modules incubator foreign, or maybe not. No, it worked. Very nice. It's extremely dummy and oversimplified, but just to give us the impression like how easily it might be to play with off-heap memory, right? When this thing gets into production. Or you can already play it or use it right now. It's just they change it a little bit with every release, right? So then it's, because it's incubating, you basically have to like slightly update it with every version of Java, just as I have to with this rolling demo, right? So this is what you have seen, and I can populate this memory, so I can use this, when I have this segment, then I can say set at index, or I can use the var handle, and here's the beauty of it, like the safety in terms of scope, so I don't extend or go beyond this arena, right? Let's say it's not only smaller but less than equal, right? Let's try to rerun it, and then it kabooms, right? Instead of writing to this memory that doesn't belong to me, it says out of bound access of segment, memory segment, this and that, right? Basically, it says it's not your land anymore. Don't go there, right? don't plant trees there because this piece of land doesn't belong to you, right? And it also applies to reading as well. If I want to examine what's inside it here, if I change it, right? And this is working nicely for a single thread. So let's see how it can work with 2 threads. Will it work? Won't it work? It doesn't work. Very nice. It doesn't work, just as I expected. Why? Because I closed this arena, right? See, this is try with resources, Java 7. Oldie, but goldie, right? And instead of waiting for it to be closed here or sort of released, I do it like on my own, prematurely, and therefore I can't examine it anymore because it tells me like, hey, it's already closed. Like, you sold this piece of land. Come on, you're not able to enter this flat anymore, right? So I can, let's fix this error. And then the other thing, I'm opening this arena as confined. See, previously I was opening it as, where is it? Where is this other call? Come on. Yeah, no, I forgot. Let's see, I can't see. It's examining, where is it? Come on, it has, let's see. It's code, it can't lie. I mean, it's not a politician, it's just a code, right? Open shared. See, I was opening this memory segment in open shared, meaning every thread welcomed, right? That's how it used to work. And now when I'm opening it as confined, basically when there's another thread wanting to just only take a look what I have there, nothing more, just take a look, right? It doesn't work because attempted access outside owning thread. And it's owning thread because it was open confined, right? So as you can see, we have safety in terms of like where I want to do that, when I can do that, when I close that prematurely, right? And who can do that, meaning as threads. So this provides us this safety. And what's important is that I didn't write a single character in C. It's all pure Java, and it's not even using like dependencies. I don't have to add anything to my POM XML or Gradle's build, right? It's just pure Java. And this is really nice about it. I like it about it, right? Okay, so this is the memory, and you might be wondering, okay, but it's like, okay, it's very nice for people who are playing with off-heap storage because it's fast for them, right? So the garbage collector doesn't right, come in a way, so to say. So the other thing is foreign linker API. It's a preview feature, right? And it's meant to replace JNI with pure Java development model. Again, this .h, .o, .c, whatever files, right? And it supports C right now in these 2 architectures, but it might extend to some more. I'm not so sure about this x3086, right? Because reasons. Again, performance shouldn't be worse than of JNIs. And what linker allows 2 things, down calls and up calls. Down calls, it's simple, just call piece of native code and does stuff for you. And up calls means you're calling again native stuff, but you're also providing it sort of a pointer to another stuff. And the closest thing would be like a comparator, right? So let's say sort this array for me using this comparator written in Java. That would be up call. And it works like this. So I want to say let's run the last demo today. I hope. And there will be off, yes. And what can I use for it? Of course, test containers, right? Because it's great for testing stuff for real. And previously, when I was showing this demo for previous versions, people were saying, yeah, but I can't run it because you can run it because you have Linux, and I can't run it because I have Windows or Mac. Now we all have Linux because we're using test containers, meaning Docker, and the thing inside will be Docker, right? So you have no excuse. Now we have to run this demo at home. Or at the conference, like at the company, you create like what this event, like what I have learned at Devoxx, right? And then you show your friends during lunch break or brown like session, like, hey, now we can do that even in like Windows. Come on. So again, I have this code, Control-Shift-T. Yes. What does it do? Have you been to Brian Vermeer's talk about Java security? Right. One of the lessons learned is don't run your stuff as root, right? So now we can put this logic into our program. right? So it can get UID. And then if the UID says it's root, the program might say, no, please don't run me as root, I'm off. Basically, right? So we have to get this UID. And previously, people were using MX bins, right, for Java to determine that. And now, what can we do in using like foreign memory API? We can get the linker, right? First, I have to read this manual, right? You have to be friends with Spanish people, and you have to be friends with manual. Right? So you read manual and you know that there's the function called getUID, and this is what you have to know, right? And this is what, I mean, as far C as you have to go. And so I'm creating native linker from standard library. I'm sort of getting the handle for this function, right? getUID, and then I have to tell sort of like it's going to return me Java integer, right? So Java short, sorry. So this is kind of like method signature or function signature. Like it's oversimplification, but it will do. And then I'm making a down call handle and I'm calling it to get the ID of the user that's currently running it, right? And then I check if it's root, if it's UID of 0, right? And then I can run it. See, again, I create a Java image, right? I put my program there, and by default, Docker runs its stuff like as a root, right? So I expect it when I run my program that it's not going to return 0, and it's going to abort with some other code, right? And it's going to say, oh no, don't run me as root. So let's run this. Let's keep fingers crossed for the last demo, if it works. Yes, the test has passed. So now, despite being Friday, we could deploy it to production and be sure and be confident that this code won't be misused by our DevOps, right? There's lovely people, but they also do mistakes sometimes because they're just people like we are, right? So as you can see, if any of you have Windows or Mac or no, for FreeBSD it doesn't work. You can run this piece of code and make sure it works properly, right? Yes, okay, very nice. And there are some other things, some varias. So people ask me, like, okay, but I'm not going to like rewrite my code to Java 19 or 20. I don't need these features, especially that they are not standard features, right? So why should I be doing this? Okay, you may take your jar, right? Your jars that you're producing from your build pipeline, even in Java 8 or Java 11 syntax and whatnot, and just run it on Java 20. Because you will have benefits from garbage collectors. For example, your stuff will be running faster without even recompiling it, right? That's the beauty of it. That's why you should have the latest JDK installed in production, okay? That's the reason, unless you're extremely wealthy and you don't mind, throwing money left and right. It's as easy as that, really. And there are like lovely entries, like what have been like the performance changes or improvements to that, like the like flags and whatnot to the garbage collectors, as you can see. Who has problems with their Java application starting too slow? Who's using Spring? Okay, that was mean. That was mean. Sorry, we have to cut it, right? We can then if you can go for Graal, of course, right? And if you can't go for Graal, you can then go for CDS archives. Basically, it will, if you have issues with your proper Java application starting too slow, it will give you certain improvements if you employ CDS archives, because the process won't scan your whole class path every time you start it, right? It's sort of like cache for scanning the class path, right? So you DuckDuckGo or Google for CDS archive if you have raised the hand for the first time, right? And this thing gets even better because now it's or can be generated automatically for you, this sort of cache, right? And there's been changes also. So now Java adopted Unicode 14 and 15 because we need more emojis. Apparently. No, but there are also like this, also other stuff, not just emojis, right? So if you are overwhelmed by a lack of some emojis, check new latest Java because maybe they're exactly the ones that you've been missing. There's 57 ones. Okay. Turns out that for 20-something years, we've been printing to standard output an error like savages because we didn't know what encoding that was. Now we can. There are new system properties. You can check system property for these two and these two guys, and now you know what encoding that is. I mean, it's probably UTF-8 anyway, right, these days, but in case of weird setups, you know. There are additional datetime formats. If you fancy to know, like if it's, for example, you need to know if it's afternoon or I don't know, evening, or it will be translated to Polish like po południu or wieczorem. Very nice, right? And there are new methods in hash sets and hash maps. So if you know, for example, that you will have in your hash map 1,000 elements, instead of creating a new empty one and make it growing when you populate it, and the old version has to get a garbage collector, and it's slow. If you know already you're gonna have 1,000 elements, you can say, give me a hash map capable of storing 1,000 elements. Okay? Yes. And so for hash sets, some stuff got deprecated, like locale constructors. Now we have to, if you want to have new locale, you just call locale.auth. And URL constructors as well. You just construct URI, and then you call to URL, if I'm not mistaken. And this is preparing us for Valhalla, if I'm not mistaken, so value objects, right? Good stuff. Some stuff got removed. So now suspend, resume, and stop will throw unsupported operation exception just as if from all threads, right? Just as you've seen for virtual threads. So this is a new thing from Java 20. And support for Java source target release Java 7 as a version 7 has been removed, right? So using Java 20, you can't compile stuff to be run on Java 7 or JDK 7, right? It will be Java 8 at least. And there's some stuff happening like to what we're gonna see in the future. So we're gonna have string templates in Java 21. Right? Great thing. We're going to have sequence collections. We're going to have record patterns and pattern matching, the thing I was showing you, or Piotr and Hanno, as standard features, right? So these switches will be working like right off the bat starting in September. That's why you should start writing them now, right? And it seems that this JEP proposes to finalize virtual threads in JDK 21. It seems that in Java 21, virtual threads will be real thing, not incubator, not preview, like a proper real thing, okay? Using fork join pull, but real thing. Okay, have you been learning Java anytime in the past? Has anyone wrote this main method? Right? And you were wondering why string this fancy characters args, or what does static mean, right? And so it was this ceremony to say, sorry, I had to yeah, this is in French, sorry. Hello world, that's hello world in French. Yeah, so just to say hello world, you had to write all these things. And now good luck explaining people why these things, right? And so it will be simplified. So you see no like string arguments, this class won't have to be public, and it can go even better with just void main. So you'll be able to call it, and then you can call it just from Java. You don't have to go for, but this was like from Java 9, right? You don't have to go like Java C and something. So you'll be able to create like scripts in Java without wrapping this in anything, but just void main in Java 21. And there are also like other great things in Java 21 happening, right? So see, this is like as a preview, still preview, but this like, no way I'm gonna fit all this in 2 hours. No way. No. Yeah. See, changes to Shenandoah, changes to ZGC. I mean, I checked yesterday. There were less than this. Okay. Great stuff. I love it. I love it that we won't be able to cover it in 2 hours. That's perfect. See, this thing has almost 30 years and it's still kicking. Okay. So now. Always, everyone, for every talk, you know the drill. You pull out your smartphone and you cast a vote on this talk and any other talks, s'il vous plaît, right? Because it's important. We need to know what you liked, what you didn't like, what should be improved, what you shouldn't mention, and do that at conferences, at meetups. Like, just tell people how it was. And it's in your own interest, because then most probably you'll be given next time better stuff, right? Yes, I accept feedback in a form, can be paper, but please go to this application. In case you can't go for application because reasons, or you're watching us on YouTube, where's the camera? I don't know, that one. This link is somewhere there. Please scan it and provide your feedback as well. And don't forget to hit the subscribe button. Yes, that was it. Dziękuję bardzo. Thank you very much. If you fancy, you can follow me on Twitter or Mastodon, and slides of today's presentation are here. And now enjoy the break I save you so we can have the lunch faster. Go!